Okay, chemists, we're going to do a different type of problem now. This is going to be a dilution problem using the so-called dilution equation. This is the dilution equation in the top left corner there of that. So it says M1V1 equals M2V2. The M is molarity, the V is volume. If I take like the most kind of specific and direct units that would make sense for this, molarity is always moles per liter. Okay, so that's moles of solute per liter of total solution. And if I require V to also be in liters of total solution, then you'll notice that those cancel, the liters cancel, and I have a mole left over. What the dilution equation is really doing is it's simply just saying the moles of solute, so the thing you're dissolving that you start with, is equal to the moles that you're going to end with. And the ones up here, I like to think of that as the initial, the beginning, and the 2 is the final, like what did I have at the end. Now there is a little detail that you have to be careful with the volumes. That's going to happen in this sample problem, and so we'll loop back to that in just a second here. Okay, so if you take a moment to read this statement, if you haven't already, this student has a small volume of a large concentration, and they want to make it more useful by making it a lesser concentration. And so we're going to dilute it by adding some water here. So I'm going to mentally think of the ones in the M1V1 as my initial, and I'm going to say that I have 3.0 molar, that's moles per liter. I think I'm going to write it out like this just to try to prove a point for a second. Times V1, the initial volume. Now I could do a unit conversion on this and put in liters, and that would cancel like I was showing you in my kind of generic equation. I want to show you that as long as you're consistent on both sides of the equation, you can use other units. And so let's use milliliters for this just to try to prove this point. 56 milliliters. Now alternatively, I could have put in 0.056 liter. Those would have canceled out. All right, is equal to M2V2. And so over here, my M2 is going to be the smaller concentration. Now I am choosing to write the molar. Capital M would have been fine for molar, but I'm choosing to write it out here just to try to show something. V2 is going to be my unknown in this particular thing. So if I look at what my units are over here, I do have mole times milliliter in the numerator divided by liter. That's weird and funny, and it's not a very kind of like agreeable set of units. However, because if I'm consistent, I will still have unit agreement. So in my case, this has to be in milliliters here. So let's solve this out. Let's solve for V2. Now I'm going to let the mole per liter come over into the denominator here and cancel out these moles per liter. And I will have milliliter left over as my particular unit in this problem. So I need to type this into my calculator. 3 times 56 divided by 0.25. So I'm going to find 672 milliliters. Now, if we're being really good about our significant figures, like I'm starting to ask us to do, we may end up rounding this to 2 sig figs, which is all I had up here. So I'm going to say or 670 milliliters. That would be an answer according to sig figs. Let's hold this for a second because it turns out I'm not exactly done. This is the total volume in that particular second-hand solution here. That kind of pardon me, this is what I wanted in this equation over here. But if I really critically go and read the statement, it says how much water needs to be added. Well, there was already some amount of solution to begin with, and I've only added a certain amount of water to have a total of that volume that I just calculated. So this guy right here. So if I want to be really careful about this particular problem, the V added is going to be equal to the total volume minus the amount that I already had available, which was the 56 milliliters here. Okay, so if I do this, now I'm going to subtract off the 56, and I will find that I had 616 milliliters. That is my final answer. That is not according to sig figs. If I want to throw sig figs into here, though, remember this was only good out to the 10ths place, and this I know in the 10ths and the ones place, but I would only be able to report this number also out to the 10ths place. And so if I'm doing sig figs, this is what I would report for my final answer there. Okay.